I thought, why should I talk about something boring alone? We could talk about something boring together. So the idea for this is that we share something with you from the NEOS labs. That is something we're currently thinking about and which is really raw thoughts and has not been put into some polished code yet, for example. But that is something we discuss for the future of Flow. It has been mentioned already. I want to do a little discussion here, a little discussion and explanation panel about the topic CQRS and event sourcing. And just to give you maybe a better idea about what it's all about and what problems we have. So we have Basti here. Basti experimented a lot with event sourcing and CQRS, and especially in domain-driven design, or in general domain-driven design. Just has been at the domain-driven design conference in Brussels and was completely stoked after that. And Sebastian is our universal looked into everything already guy, so is the joker we always have on stage. And Christopher is, you know, the I doubt that this is a good idea guy who will ask the difficult questions, the hard questions, yeah. And I personally also did some experiments with Flow and event sourcing and CQRS. So, yeah, before we start about discussing the topics, we should give you a little introduction. So, I'll ask again, let's see how much I can see that. I mean, who has at least heard about CQRS? Okay. And event sourcing? Okay. Who has used CQRS? Huh? Event sourcing? What's the difference? That's what I thought. And actually, it was the same for me, like end of last year. I read a lot about CQRS. I understood the pattern, so I thought. And I heard that when you use that CQRS thing, you also use this event sourcing thing, and maybe that's a plugin you install or something. But no, but to really understand it, you have to see it in the context where it makes sense, and also when you start using it, it will break your brain and raise a lot of questions. I'll try to give you a little example about when that makes sense, and then we put it into a larger context of domain-driven design and so on. Just imagine you have a shop, a web shop, and you can put something in your shopping basket and then go through the checkout process, and then you order something. Then what you traditionally do is, of course, you have on the server side some objects you're dealing with. You have a basket, you have some order object, and you have later on for the invoice, for example, you have line items and so on, and persist that somewhere in the database. The database is that place where you always can find what the current state of your application is. If you want to look up which customers exist, that is where you look, and because you're using transactions, it's always consistent what you find in there, right? That is how we are used to work. Now, with event sourcing, I'll start with that part. It's all a bit different. Actually, when your application is based on event sourcing, you don't have a particular place where the state is stored. So there is no customer table where you can look up and definitely see this customer number, this customer exists. It is probably consistent what you find here and there, but not guaranteed. So what you do is actually you make sure that every change in your application, everything which modifies the state of your application, can only be done through events. And how do these events come up? When you combine it, for example, with CQRS, then you start with a command that is handled somewhere, does something, and then results in some event. So, for example, when I put something in the shopping basket, I will have some put item into basket command. So that is also how you phrase it is very important in these contexts. You always have a verb like an imperative which says do that. And then it is handled somewhere, and when it actually is okay that it should end up in your shopping basket and has been validated and so on, the result will be an event called item has been put into shopping basket. And that event includes a bit more metadata, so you know what kind of item you picked and so on. Now, you proceed and put something more into the shopping basket and remove things again, and then proceed to the checkout. And even your invoice won't have a database table or something. You will have events like invoice has been created, item has been added as a line item, and things like that. And when a bit later you want to know what's actually in that shopping basket, what's actually on that invoice, which customers actually exist, and how did they change their addresses over time, and so on, what you actually do is you need to replay all the events which ever happened in the correct order. So you will really replay history. You say, okay, the invoice was created, something was added, something was removed, the quantity was raised, and so on and so on. And then when you end up at the last event, then you can actually look up the domain model and see, okay, that is what it supposedly looks like today, or at least a minute ago. And so that sounds pretty stupid because it doesn't sound very performant, right? Now, when you see that, I drew this with my very own hands. You can also see it there.
This is not a logo, by the way.
This is not a logo.
This is not a diagram.
I told you. I wonder why I asked Christopher to join us on stage. It will be very hard. No. So what we've been talking about so far is from the client, that is your user interface, for example, you send some command, and then that ends up in your write model. You know, you have changed something, you've written something, and that is your domain model. And that, if you want to know what that write model looks like, that is based on events only. It is sourced by events.
But it's still a domain model like a PHP class.
Yeah, that's a PHP class. Only exists in PHP. No, it's
only
so what is a domain model actually is still, a domain model consists not just of setters and so on, and especially in this case, you try to make it very verbose, so you don't have set this, set title, set line item, and so on, but really try to make it meaningful and say, sign up new customer, for example, or I don't know, promote customer to top bonus customer and things like that, methods like these. And the domain model knows about the business logic, what is allowed, which conditions need to be met in order to do that, and so on. And then we'll create an event. For example, customer has been promoted to top customer, or user tried to sign up with invalid email address, or things like that. So that is the write model. Now, imagine you have your shop again, and you have one screen where you want to show to your customer which orders he has placed in the past, if they already have been delivered, and what the amount was, and so on. What you traditionally would do with a database is you would do one query or lots of queries with lots of joins and across all kinds of tables in order to produce that view, right? What you do with event sourcing and CQRS in particular is that you create one model. You could also say a data transfer object, if that means something for you, to you, which is tailored to that view. So for that overview, you need one model which contains the order number, maybe a subject, the amount, and the status if it has been delivered. And ideally, you put that into a database or into some Excel sheet or whatever, but the idea is that you just can read it and display it right away. And that is the read model. The read model cannot be changed. It doesn't have any setters, right? Because that is just for reading. And how does that read model exist? Well, there is someone listening for all the events, and that is called a projector. So that projector will check, for example, events like invoice has been created, invoice has been sent, and so on, and will update that particular read model for you, that particular database table, which contains exactly that specialized view. So that means that is, yeah?
Yeah, it does work. Just to add something on top, it doesn't have to be a database table. It could also be an Elasticsearch index, for instance.
Exactly. So these projections could be really anything. Imagine the NEAS user interface, for example, and you have the document tree there for each user. What you could do is react on all the events which happen, like node has been updated, moved, and so on, and then always update a JSON file for a specific user, which only needs to be read by the user interface and can display that tree right away. I mean, it would be an extreme case. Let's see.
Won't work for architects.
Yeah, but a projection can really be anything which is useful for you. And now the really nice part is you don't have to know in advance which kinds of projections you need, because you always have all the events stored somewhere in some event store and can always replay them. So coming back to that shop idea, someone discovers that one item is not purchased as often as others, and you want to see, for example, do people actually put that into their shopping basket but then discover something else and remove it again and then order something? What you usually do is you start tracking customers, and so you implement some tracking in your shop and then watch that during the next weeks, and then you can analyze it. What you can do with event sourcing is you already have all the data from the last 3 years, and you can create a new projection which analyzes the events you already have, and then you have some really meaningful data.
But if you have so many events, so doesn't it get a lot of work to replay all these events for the last 3 years just to get to the point to see what's in the basket? So,
yeah. So before we get to that, the question is no? No, we definitely talk about that. So the question is there anything else needed to understand the overall concept?
I think that's pretty much it. I think it really boils down to that the read side gets a lot easier because you don't need to, if the read side is wrong, it's not a big deal because you can always fix it and replay the events and get to a correct state again. And it's like something, a throwaway code in some sense, I mean, it doesn't, because it's very easy to change, and code which is dealing with persistent data is normally not very easy to change because you need to do database migrations and these kind of things. And this basically gets a lot easier by using for the read side of at least of event sourcing. Yeah.
So let's deal with the performance.
Let me chip in one more controversial thing just to make it more fun, because you said it's gonna explode your head or it's gonna be more complex. I would argue that actually the core concept of event sourcing is actually more natural than what we do today. If I remember back when we thought in database tables, we can come a long way from now thinking in objects, and some people still have too much structure in their head. But of course, all the tools are too much structure. Well, you know what I mean. Yeah.
We are fairly unstructured.
It's been a tough week. Anyways, we learned to think in terms of state and structure, but actually, what is in the real world, what is more important, or what your brain thinks in terms of events that happened, and it's the difficult thing with the whole OR mapping and so on. The tools are difficult, and that doesn't. I mean, if you look at it, you have to learn a lot of new concepts. But the core idea itself, I would say, it's a mind shift. You have to learn a different way of thinking about your domain. But I wouldn't say it's more complex than what we have.
Yeah.
Well,
So
probably the devil is in the details then, right? I mean, like the overall concept is pretty unnatural to think about, but then of course, you know, there are a lot of things. If you start to implement it, it's like, oh, how do I do this? And you perfectly know how it works in the old way.
I think the main reason is because it's relatively new concept compared to for OR mapping, for instance, where in the beginning it was a hell as well, and then tools like Doctrine in the PHP world.
Let's talk a bit first about consistency, because that's in a very interesting part later on performance and so on. But let's talk about consistency. So we are so used when we're dealing with database tables that there's always that single source of truth where we can look up things, and we do a lot of effort to make that very consistent, because if it's not, then everything is chaotic, right? So how does that, I mean, I think, as you said, event sourcing is more in a more realistic and natural way, because in the real world, we don't have consistency either, right? So
to be more clear with consistency, you mean consistency toward the client or inside the data, or what do you mean with consistency there? I think it's maybe not clear.
Exactly. So I hoped you would.
What
does eventual consistency mean?
Consistency. I would say so. I would say it's a different topic, because it doesn't mean you can go event source and you're still completely synchronous. So that means so you still, at the time I create a user, at the same time when the request is through, in one transaction everything is your read models are up to date. But obviously, in a big scale, that won't work. I mean, imagine you would order something on Amazon and they would block your browser until someone actually put this book or whatever you bought into the package. Right? That doesn't work because the world in general is not synchronous, and in most, at least in complex scenarios, you have to cater for that, and that's where eventual consistency comes in. What it means that, in contrary to immediate consistency, we can be sure that at some point it will be all in sync, but it doesn't have to be in one transaction, basically.
I think that the point is also that like immediate consistency is something of a trap. I mean, it's very easy to reason about, but it's usually not the case, you know? I mean, if the server crashes in the wrong moment, if, I don't know, some disks have problems or whatever, there are lots of ways things can break. And basically, so we are thinking that it's all consistent when we put it in a database, but it's not, right? I mean, so the difference, I think, is also that we acknowledge that the world is not perfect, and there are things which can go wrong, and we have to keep that in our minds, and this is what CQRS forces us to do, and event sourcing forces us to do, which also makes it at first difficult to think about, because it's just different than we are used to, as you said.
So, simple example for eventual consistency that I think everybody knows would be, I change some node and I have a search engine on my side, and maybe it could take some time until I find it in the search. That's eventual consistency. So if I do something and refresh and it's not there, at some point it shows up.
And the question is that bad? I mean, right?
Yeah,
I
don't know
what about
that.
the real world? So I think domain-driven design is always nice because you always can try to imagine how would that work in the real world without a computer. Like, so if you come to some insurance company and there are 10 persons working and you create a new contract or something, and someone at the next desk would look it up, it's not there yet because, I mean, that is not synchronous. That's not that. Or for example, if they have to invent new customer numbers, there could be the same customer number at the same time. So the question is how severe that problem is. And what I like about that approach is that they are really pragmatic. And for example, what not cashiers, Geldautomaten.
So
ATMs, yeah, that was a abbreviation. So ATMs, for example, they are also not working synchronously. When you go there and someone blocked your bank account, then probably that ATM doesn't know that yet because it has 15 minutes old data. But creating a system which would allow ATMs to look up everything in real time and lock everything before it does something
would be way more consistent.
That would be way more consistent, but would be very, very expensive. And so the question is, what could go wrong? So if someone closed down your bank account 5 minutes ago and you get some money, well, they have your address, you know, you have at least been a customer, so the risk is really low, so that's why they don't address it at that point.
I mean, that example, it's a really highly distributed system with lots of components, so that's where I struggle a little bit comparing that to more simpler architectures.
I just wanted to say this.
What I would like to question is eventual consistency necessary to implement CQRS and event sourcing, or is it something on top? So
I would say it's exactly the other way around. Just to recap, I think even so eventual, or I mean, just to agree that being asynchronous is not only important in the large scale. We even realized that with Neos, when we try to update the Elasticsearch index, and it just makes the thing slower because it, and the audit log, we created this audit log module, and it's difficult not only because it's slower, but because, well, or you can then introduce some kind of asynchronity, and that's always a hard thing because it might get out of sync. For instance, whatever this Elasticsearch server is not reachable for a while, and then it's out of sync. And that's where event sourcing just is a very natural tool that makes it easy to use. So I would say it's actually a completely different thing, but it makes it really easy to get event sourcing.
So I could have some parts without event sourcing and some parts with it. So either. Depending on I have synchronous and asynchronous
I think it's extremely important that you can really mix and match that it's not like the one thing or the other, and you know that everything we've done in the past, it's not like wrong by now or anything. It's really just another way of doing things which fits well in certain domains and which is very helpful in certain contexts, basically. And we basically also, so I mean, you might wonder, why are we doing all that? I mean, like, it sounds like this, you know, like university discussion, oh, well, and they are ping-pong with ideas. But we've been thinking also in terms of what do we want from the user to work with Neos? What features do we expect which are just simply not really possible in the current architecture?
Yeah, give some example. What do we want to do with it?
For instance, I would like to have a complete, you know, if one user moves something pretty much on top of the node tree, for instance, another user changes content inside, that creates a conflict currently, meaning that the one or the other user will override the other one.
When publishing.
When publishing, exactly. And it could even happen if there are bugs in there, and this might well be because it's very complex code, that you even lose something without even noticing. So And you know, if we had the exact information, okay, this guy didn't want to touch the whole subtree, but just moved this one single node, and the other one changed things below, it's extremely easy to resolve that conflict, and to actually, you know, they can do that without any trouble. And so that is, for me, the most basic example, but there can be a lot more. I mean, I think
it's not so basic, but it's a good example. Yeah. So it should be possible to merge these different operations, which
you have to say it's really extremely simple, but only if you happen to be Sebastian Kurfürst.
Okay, no, but because you know the intention, you know.
Yeah, exactly.
I mean, without event sourcing or commands, you only know the result and have to guess what led to that result.
Yeah.
And when you know the events, you can actually see, also actually for development, for debugging, you can actually.
Yeah. This is, for instance, something. So we've been talking about the React topic, and actually. This is also somehow related, although it uses different terms, but the general idea is pretty much the same. We have some state, and then there are commands coming in. They are called differently there, but it's still the same thing. Like you click a button, some content is loaded from the server, these kind of things. And so what we get is a full list of what has changed in the user interface. So the full audit log, basically, of what the user did, and if he runs into a problem that is completely reproducible, so if we have the full audit log, then we can debug exactly the point where things go wrong, and this is so extremely valuable. So there are even tools where you can, in the browser, where you can toggle, you know, say, okay, let's try to remove this event and see what happens, and then you see the UI updating immediately. This is totally crazy. When I saw it for the first time and experienced it myself, it was like totally mind-blowing.
Okay, so I think we should stay on the server side. I think it's a good point, but will we just put another concept into that? And I just wanted to ask, so I can do undo with that, for example?
Yeah.
With the audit log on nodes and have more intent and show a nicer workspace overview, and when publishing, we can check if things have conflicts in a better way. So. And it would be much easier to implement moving of nodes, because that's one of the hardest things right now.
And we get basically for free, we get a stream of what has changed when, and this is so valuable as an outside API. Imagine you would like to, I don't know, in Neos, we've been talking a lot about this content mix stack, you know, and data flowing into the system and data flowing out of the system. And this fits so extremely naturally to this model that basically we already have events, so they can just also flow outside the system if you want. So you can synchronize things. So if we go more to the advanced side, it would be so easy to synchronize one Neos instance with another one if you want that.
Again, only if you happen to be Sebastian Kurfürst. It's really simple.
Well, I mean, conceptually, not in detail, you know?
It's possible. I mean, at least that's... just one more example. Maybe some of you remember the very old UI designs for Phoenix back then, it was called. And there was... they were done by a designer who didn't care about what is technically possible, so there were some really advanced things, like a slider where you could go back in time and see what happens in that time in real time. That's something that will be, I mean, not very easy,
but at least we have the data.
It would be possible to create some kind of read model that is separated from the tree, that is catered, that optimized to show the history for certain nodes, for instance.
So let's talk a bit about projections. There are a few interesting details about projections. One thing we already mentioned was that at a later point in time, you can decide to analyze the data and use it for certain things. Yeah. But of course, there are all kinds of tricky details also to it, and some further advantages. So one thing I'd like to mention is when you try to scale some application and need to deploy it. I think there was some aha moment for me, for example. So when you now have a Neos website which relies on a certain database structure, and you have 3 web servers running that website, and you deploy a new version which contains a different database structure. It has a bit changed, and it's not downwards compatible with the currently running application. So then you have a problem, because when you deploy the new code, you cannot deploy everything exactly at the same time, so there will always be some part of your application running which won't be able to handle the new database structure. Now, when you're dealing, when you're using a read model, you will have projections. So, and they, of course, also have a certain structure. So it could be that the new code which you deploy also comes with a new structure for these read models. But what you can do is that during that deployment, you create a new table for that new version of your read model and replay all the events and warm up that projection. And then over some time, you can actually have two versions of your application running in the cluster at the same time for an hour or so, if you like.
Won't that get conflicts or consistency problems?
You will never get consistency problems because you will never write into these tables because it's all handled by events, yeah, right? And these, you still put them into an event store, and that, of course, is a very critical part of your application.
You need to get that one right.
But it's also a very, very easy part, because if the event store is really easy. I mean,
who's right?
It is really just imagine a table, and one line is one event, and you will never change it again, because you're not allowed to change the past. You cannot do that in practice either. So. In practice, for example, what they use is atom feeds, and then you have one URL for like 50 events, for example, and when these 50 events are full, you can cache them infinitely and use, for example, a varnish cache, putting that URL in there, and then all parts of your application can actually read it from there.
So that means I need a new database for that, or?
Well, technically, no. I mean, it can be.
It can be a database, but
it can be anything where you can put things.
It can be a directory with files.
Currently, I use it in a project in a pretty big scale, and a database is an option. It doesn't perform very well if you have a lot of fast incoming events, for instance. And there's this one project, getEventStore.com, by the actual creator of the term CQRS, Greg Young, and this is a pretty neat tool, and this is optimized for this high scale. Yeah. But I think more important to really understand the idea behind this is and why it makes sense is a common example is the accounting, where you have your bank wouldn't store your account number and then some column where it stores your current balance, and then when you take out money, it would just reduce it, and then well, that's not how it works. They have actually an event stream, and that's exactly. I mean, it's not a new concept in that manner. It's been like this for ages. It's just now it kind of gets picked up by the whole domain-driven design movement, and I think that's also something we could maybe put it into perspective in terms of where does that fit into the whole domain-driven design world. Because for some people, I think it's still a completely different concept, but I think it's actually exactly in line with the ideas.
I would even say that all the trouble we got from relational databases only happened because storage was so expensive. So I think it's just optimized for storing really, spending only few disk space, and then now that it got much cheaper, we start to denormalize data. We have duplicate data in Elasticsearch and everywhere, and now it's also realistic to have an event store, for example.
Yeah, that wouldn't have been possible like 10 years ago or something. I mean,
so takes time. Maybe back to that question. With the lots of events. So imagine you have a shop and you collect events for 3 years with basket operations, customer creation, orders, delivery, whatever, product creation. So it's a huge amount of events. So at some point you need to know what's the current product state. Is it deliverable, or what is the customer state? Let's stay at the basket example. What's the current basket content for that customer? So, let's try to explain how you could do that with an event store. Yeah.
One important thing, and that's where it's exactly related to domain-driven design, is technically you might have like one huge event store that stores all your events, but conceptually, it's one event stream per aggregate. And I mean, no, I guess lots of you work with flow, so I think you have heard that term already. So it's not like you have an event, you have to replay all events for like everything in your system.
So the customer would be the aggregate or the basket?
Exactly.
Or?
A customer, for instance, is an aggregate, and usually
not the type customers,
no,
but that particular customer.
Yeah, one instance, and that is important because usually you might have a lot of events in your system. If you have a lot of customers, you have a lot of events, but usually one entity doesn't change so much in their life cycle. And if it does, it might be a sign that you have your aggregate boundaries wrong. And yeah.
That's also great for scalability, right? I mean, because you can store the events for clients on the one side and the events for baskets on the other, if you like.
Yeah, even on different systems, that's what I mean. I mean, if it's just, there's events can be triggered by some user interaction, so by a command in that sense. But it might also be some telemetric data events that come in within seconds, and then you might have different requirements on the scalability there. So you can just separate that out, but use the same core concepts.
And there's also that concept of snapshots.
That's also, of course, if you have these streams, and then once you get to the thing is, they actually you can replay them pretty fast because it's one query you send to the database. You get all the events, and it's pretty fast. But let's say you have
to process them in, for example, PHP to apply them to your write model, which starts blank, for example, and then all the events on that aggregate are applied.
It's true, but then first of all, you only rewrite. Just to remind you, only replay them during writing, because during reading you have the read models, and writing usually is, in our common cases, it's not the common case, right? You have a lot of reads, but then you only change data not so often. But even then, it might happen that you have 1,000 events, especially this customer probably won't change 1,000 times in its lifetime, but maybe if we think of the node SCR, that is pretty possible that you change it a lot. And there is a concept of having snapshots. So, for instance, let's say every 500 events for one aggregate, you can kind of store the current state of that. And then when you replay the events, you only go back to the last snapshot. So you would have 499 at most.
But you have to define that state yourself, how that snapshot looks, because I was somehow define. I think it's a complex.
That's actually a really important thing, because I thought that contradicts the actual idea of, because now you have all the freedom of creating your read models and then throw them away, create them. But if you have snapshots, you have to decide for some. But the snapshots you can actually also throw away.
Yeah.
Of course. I mean, right? If you decide you change it, you just create them anew. I mean, it might be an expensive operation, but that's not. I mean,
snapshots are just performance optimization, which you can use or not. You wouldn't start with them. Right? Okay. So let's take a step back on a high level again. So I see lots of advantages in domain-driven design, but also in CQRS and event sourcing. And of course, it's a difficult topic, but once you're at it, you feel like you see event sourcing everywhere. You know, like when I come at home, I see, has the mail has been put into my postbox event already happened? Let's see. And so open the lit command. So you see it everywhere. But so what are the drawbacks, and what would you say, for whom is it really?
What I would like to ask, how much more effort is it? So I have my, let's have a shop with customers and baskets, so I do it with classical entities and one storage for both reading and writing. How much more effort would it be to do it in CQRS and event sourcing? Because,
I think a really important thing is you don't do it in CQRS or you don't, but you decide which parts it might be useful for. And then even one of the creators, they wrote this blog post saying, when do you need CQRS and blah, blah, blah. At the end, actually, never, almost never, it says, I think. Because the thing is, it is quite complex, and if you don't really need those advantages, or if you can realize them some other way, like if it's not a problem for you to be synchronous and so on, you don't have to do that. And Yeah, I mean.
So we don't need it.
And especially you can pick and choose, and that's the important thing. You want to use that in your core domain, in that thing that you want to be different from the other. If you just like that, and that is, I think, the really difficult part to define what is.
For the nodes, for NEOS, for example, you would use CQRS for the nodes and the event sourcing, but maybe not for the users in the system.
For example, yeah. Okay. So I think we need to wrap it up, but I would think now when looking at that topic, so I think domain-driven design, we just have seen the tip of the iceberg of domain-driven design in Flow, and we didn't talk about domain events and so on, and also these concepts of boundaries and so on in context. But it's definitely worth a look at it, but also it requires quite some skills and experienced developers. You can draw a lot of business value from it, so it's definitely worth the additional work if you can draw some additional information for your business, for example. But it's probably not going to happen that we say what we now have as action controllers and so on, that we just throw that away and say from now on you can only do.
I think the important point is that basically if we apply that to the core of NEOS, which is the content and the content repository, that means that we, of course it's quite some work, it's difficult to get that really good and we have to try it out in a lot of ways to get it done, but once we have it, then everybody of us will profit from that. I think that's the main point. It's, as an end user, you'll probably never notice it directly. You will just see that, the CR is still fast, even if you store millions of nodes in there, and it still works nicely even if hundreds of editors edit at the same time, or it's still it's possible to synchronize the content near real time to external services, these kind of things, and this is like what is very, very difficult to do in NEOS, consistently and in a good way today, because we just have the snapshot of the current state and we have no clue who has changed, what, when, why, these kind of things, right?
Yeah. So CQRS and event sourcing will be additional ways to work in Flow, and we'll use it for NEOS.